Hey, Algebra 2. Today we're going to do 7.2 arithmetic sequences. With that in mind, let's talk about what an arithmetic sequence is. It's a special sequence that basically means you're always adding or subtracting the same number. So let's look at here. I'm adding from 3 to 5, 2, 5 to 7, 2, 7 to 9, 2, 9 to 11, 2, 11 to 13, 2. So I would call the difference, or we're going to use the letter D, is 2. Okay? So D, the difference between each time, is 2. And we're going to use an equation to first find any point of the thing. So if I want to find the 100th step, instead of doing all steps up to 99 and then finding the 100th, we're going to figure out a way to find the step that we want. So how does this equation look like? It looks like this. A of n, and this is also in the Google Classroom, so you need to copy this out. But A of n is the point where I am looking for. So let's say if I'm looking for a point, where is it on the 100th step? So I want to go to 100 pieces. You put A 100. It's also generic in the way that it's kind of like Y. We leave it blank or leave it as a variable most of the time. A of 1. A of 1 is going to be your first step. First step, okay? D is going to be the difference. Like we talked about, what is the pattern between it? I said adding is also subtracting too, because remember, subtracting is technically negative adding. So it could be like going down by 2 or going down by 100 or something like that. Parenthesis, n minus 1. N is what step you're, minus 1 is just minus 1. It's just subtract 1. So n minus 1 is lowering 1 each time. I'm sorry, not lowering 1. Is whatever your step is minus 1. So instead of just saying what it is, let's do an example. First, I want to figure out the equation for this set of this sequence. Okay? So starting at 3, it's 5, 7, 9. So an is going to be generic. We're just finding the generic equation. A1 is the first step, so that's going to be 3. D is going to be, for every step is 2. So D is 3 to 5 to 7. So D is the pattern or the rate. So that's going to become a 2. N minus 1. N is going to stay the variable because I didn't ask you to find a specific spot. All I ask you is to write the equation. I'm going to attribute the 2 to everything. So it's 3 plus 2n minus 2. Combine like terms. 3 minus 2 is 1. 1 plus 2n. You could write 2n plus 1. That doesn't matter. Equals an. So this right here would be the equation for the sequence. And this is how we're always going to find the equation for arithmetic sequence. So this equation right here is pretty important, okay? So I'm going to do another one. Let's say the pattern is 7, 11, 15, 19, blah, blah, blah. So first we need to figure out where our starting point is, A1. Our starting point at A1 is always the first term we got, which is 7. And then we need to find D, the pattern. The pattern each time, if this is an arithmetic, which means it adds, is plus 4. So we're going to plug it into the equation on the right over here and solve the equation. So A of n equals, the first term is 7, we just agreed, plus the change every time is 4, so positive 4, n minus 1. I'm going to distribute the 4. 7 plus 4n minus 4. 7 minus 4, 3 plus 4n equals A of n. Circle that. Okay? Now, what if I ask you, hey, tell me what this pattern is on the 25th step? So what does that mean? I want it at A25. I want it on the 25th step. So how do I do that? Well, a of n, or a of 25, is what is the sequence at the 25th step. We have an equation to figure that out. We're just going to plug in 25 here. So we got 3 plus 4 times 25. So 4 times 25 is 100. 100 plus 3 is 103. So at the 25th step of this pattern, it'll be 103, which I think should feel a little bit easier than doing this pattern 24 times, all the way up to 24, and then doing the last one, I guess, so 25. So this equation is to help shortcut find something else. And I think I just want to do one more with a negative. One more with a negative difference. So let's start at, let's do 15, 9, 3, -3, -9. Well, that's symmetric, but not on purpose at least. So we first need to figure out what our starting point is, which is 15. Then we need to figure out what the difference is each time, which seems to be -6, because we're going down 6. So a of n equals my first point, a of 1, which is 15. It's -6, so I'm going to put -6, parenthesis, and -1. So -6, I distribute here, I distribute there. 15 minus 6 plus 6, 6n, plus 6. Remember, -6 times -1 is going to be a positive 6. Combine like terms. 21 minus 6n. Oh, there's a little off camera, I apologize. Is a of n. And I want to test this out by just plugging in number 1 here. If I plugged in 1, it'll be -6 times 1 is 1, -6, right? 21 minus 6 is 15. That makes sense. What if I plugged in 3 here? So it should be in, this is step 3, right? So it should end up being 3. -6 times 3 is 18. 21 minus 18 is 3. So you should see that it should work for every pattern. And if we follow the equation, it should work every time. All right, that's it. We'll use this, and we'll do this in the Zoom later today. Have a wonderful day, guys.